So thank you very much, and welcome to everybody. Sorry for the slight delay. Just 1 second. Okay. So hello everybody. My name is A.Bottino. I am an associate professor at the Polytechnic University of Turin, and in this presentation I will talk about avatar interoperability, which refers to the ability of avatars created using different methods or by different systems to work together seamlessly in the same digital environment. And the reason why we are focusing on avatars is that they are very important in virtual spaces for several reasons. So avatars allow users to represent themselves in a virtual world, giving them a sense of presence and identity. But the relevant thing is that avatars can also be customized to reflect the user preferences, so to reflect their style, to reflect their personalities. And this level of personalization is what allows users to express themselves in ways that they may not be possible in real lives. So this means that the user can be represented by an avatar that is as realistic as possible, or in the same way that it can be represented by a really stylized avatar that can look more cartoonish or a little bit exaggerated, okay? And these latter options also helps maintain user anonymity. And these are the kind of avatar that you usually meet in social spaces and online games. And the other relevant features of avatars is that they allow to express emotions, they allow to express reaction through both their body and the face of their avatar. And this makes online interaction more rich and also more fun. So in online worlds, we can have different type of avatars. We can have personal avatar, which are designed to represent an individual in virtual spaces like metaverse or social media or online gaming. And then we can also have non-personal avatars, which represent, let's say, a specific role or a specific function. So for instance, a non-personal avatar can be a chatbot or an AI-powered assistant in a customer service setting. And in this case, it is often possible to have conversational avatars also, with which you can interact vocally to ask all the information that you need or discuss with them any topic of your interest. And these possibilities are what enhances the user interaction because they allow to reproduce interaction with a real person in the real world. So avatars are taking more and more important role in online worlds, and the kind of experiences and the kind of functionalities they are offering are constantly evolving. And the avatar representation animation MPI aims at providing a structured representation of an avatar that defines the properties, the attributes, and the behaviors of an avatar. Which includes also its appearance, its movements, and interactivity. So in brief, what we define with these terms. With appearance, we can define the avatar visual appearance, such as its shape, the color, and the texture associated to the object. Behavioral attributes can be defined as the avatar movements and animation, while the interaction attributes define how the avatar interacts with the environment and with other avatars, which include also communication in any form and manipulation of objects included in the environment. And in particular, MPI ARA aims at providing a comprehensive framework for designing and implementing avatars that are interoperable across different virtual environments. So our objectives are summarized in this slide. The first is to allow a user to create and share a virtual space, allowing for immersive experiences. The second objective involves enabling a user to reproduce an avatar of a third party and animating this avatar according to the intention of the other peer, and possibly using the minimal amount of information to perform this task. Third objective focuses on estimating what we call the personal status of an individual or an avatar, where the personal status can be defined as those pieces of information that characterize a person. So the sum of their emotion, their cognitive states, and their attitude. And finally, we want to provide functionalities to display an avatar with a specific persona status. So this means, for instance, that the user can portray her avatar as looking sad, even if she's actually looking happy, or the other way around. And as I told you before, the increasing popularity of virtual communication and interaction makes avatar nowadays an essential element in modern technology. And so we can have a lot of use cases, which ranges from online chat to video games to virtual teleconferencing software. And in all these situations, you can have avatars which can take various forms, again, from realistic humanoid to cartoon characters, because this allows and provide users with a sense of identity and personalization that they require and that I discussed before. And one of the use cases Empire ARA is working on is this one, the avatar-based video conferences or virtual conference, which uses avatar to represent participants in a shared and distributed virtual conference room. And in this use case, you have participants that can join the conference remotely from anywhere in the world, and they can interact with each other through their avatars. The avatars can be customized, of course, to reflect the physical appearance and the personal status of the participants. And during the conference, the avatars can display real-time animation, real-time gesture, which are based on the real participants' audio and visual inputs. So this allows for a more natural and engaging communication experience because participants can see and respond to each other's body language and facial expressions. And additionally, the Empire Array also includes features such as specialized audio, which allows participants to hear audio from specific location in the virtual conference space, and intelligent agents, which can provide, for instance, real-time translation, real-time summarization, and a lot of other helpful features. And going to details, we have separate clients that participate in the virtual conference using their own avatar to represent them, and also using their real voice to speak. This virtual environment can be seen as a room, which includes also a virtual secretary, which is an intelligent agent controlled by the system. At the beginning of a conference, participants send their face and speech descriptor for authentication. They also send their own avatar models and all their language preferences to the server. So the server then select the visual environment model, which is the virtual room in which the conference takes place, authenticates all the participants, assigns them a place in the virtual room, and then sets the common conference language. So during the conference, then participants, they send their utterances, and they also send the body and face descriptor of their avatar to the server. The server, what it does, it translates for each client the speech signal to the language requested by the other peer, and then it forwards to the receiving clients the translated signal and all the avatar descriptors of the transmitting client. And in the room, as I told you before, we have this virtual secretary, which creates a summary of a conference by combining all the recognized tests and also combining the user personal statuses. And then the receiving clients, at the end, they render the virtual scenes according to the data received from the server by specializing the voices of the avatars and eventually selecting a first or fourth person point of view of the environment according to their preferences. Oops, sorry, something not working. Okay. Here I was. Okay, so now let's make a brief walkthrough of the workflow of this use case. The user can select a variety of options, including the virtual space to join, the avatar of the model they want to use in the conference, and also they can pick the position in the room. And additionally, also the user point of view can be adjusted so that the user can select a unique perspective of the virtual environment. And behind the scene, we have a machine which is responsible for creating the audiovisual scene description. This machine receives the audiovisual components of the real environment and creates an audio scene description, which is composed of independent audio objects as well as their locations. So similarly, you have a visual scene descriptor, which is created and populated by visual object. And finally, the complete audiovisual scene descriptor is presented to the user. And in addition, this machine is also able to authenticate the users through speech and face descriptor. And then it's also able to decode human personal status by extracting descriptors of the manifestation of a user's personal status. And it takes this manifestation from various modalities like the text, the speech, the expression of the face, the gesture of the body, and so on. And the machine then animates a speaking avatar by synthesizing speech using text and all the other information like personal status of text, personal status of speech. And then it also animates the face and the body of the avatar using the previous information, along with the personal status of the face and the body and the gesture that are transmitted. So in the conversation with another party, whether it is a human or an avatar, this machine decodes the other party's personal status and animates an avatar representing it. And additionally, it can also summarize and refine the speech of other parties by analyzing all the received data. And MPI Array follows the MPI mission to develop AI-enabled data coding standards and leveraging all the Lego type AI frameworks by defining building blocks that are needed for creating avatars and animation. And these building blocks can then be combined in various ways to create different avatars and animation. So much like how Lego blocks can be combined to build different structures. So the thing is that, okay, as you know, standardizing these building blocks and their connection, this allows for interoperability between different implementations. It promotes transparency, promotes trust, reliability, also in the development of avatars and their animations. And the client-side architecture allows participants to send and receive audio and visual data to and from the server. The transmitting client receives audio and video input from a participant's microphone and camera, along with the avatar model and the spoken language preferences. And then it sends speech and face descriptor for authentication, along with participant preference, participant speech, and also the avatar descriptor to the server. During the meeting, this transmitting client generates all the audio and the visual scene descriptor that should be shared with the other participant to allow reproducing their audio and also rendering their avatar according to the animation data and the personal status, which are acquired by the AI modules. And in particular, avatar animation data are obtained by processing the input video of the camera of the user. And then the avatar personal status is extracted from both the avatar animation data and the meaning also of the speech which has been captured by using a speech recognition module. And finally, the transmitting client sends the speech and avatar descriptor of the participant to the server so that they can be distributed to all conference participants. And here is the server architecture, which facilitates communication between participants through several components. And these include the environment model, which defines the virtual space, and also the avatar model positions, which determine basically the location of each participant's avatar in the shared environment. And then, as I told you before, the server also selects a common meeting language for granting communication between participants who speak different languages. During the meeting, then the server receives and translates participants' text and speech. And the server then sends back as output to all participant client, all the translated speech, all the translated text, and all the avatar descriptor received from a client. So summarizing the function of the server, it is to centralize management of a virtual meeting space and also enabling the effective communication between all the participants. And this is the block diagram of Virtual Secretary, which, as I told you before, is an AI system that helps the video conferencing system by listening to all the user speech. It helps by synthesizing the compressed avatar descriptor and also helps in computing the personal status of the avatars. And one of its main tasks is also to create a summary of a meeting in the common language and enrich it with some graphic symbols that can represent also the personal status of a participant, so everything is embedded into the same document. And this summary can then be edited externally, and it can also be displayed to avatars for including comments from participants. And the workflow of a virtual secretary starts by extracting text from speech and extracting the avatar personal status from the body and facial descriptor. The language understanding blocks creates a final version of a recognized text and also its meaning. And then we have the summarization block, which starts creating the summary, while the dialogue processing module provides an edited version of this summary. And finally, we also have the personal status display that provides all information about textual, audio, and animation information related to the avatar representing the virtual secretary in the virtual environment. The receiving client on its side is responsible for rendering of the audiovisual scene to the other participant. So it creates the scene first using the environment model and all the avatar models received by the other clients through the server. Then at runtime, it animates the avatars of each client, localize their audio in the position of the corresponding avatars, and rendering the scene from the point of view selected by the participant. And this is a detailed diagram of a personal status extraction block, which was shown as a black box in the previous slides. As you can see, it consists of a combination of various AI modules, which are used for different purposes. So one of these modules is personal status extraction, which estimates the personal status of human or of avatars by analyzing the partial personal status information that are conveyed by different modalities, like for instance, text, speech, face, gesture, and so on. And then the final personal status is obtained by putting together and processing all these different estimation of a personal status, which are computed by all the different modalities that are available. Then this personal status can also be displayed, and this involves using different types of personal status information, such as speech, face, gesture, and also combining them with the descriptors of the avatar's face and of the avatar's body to generate in the end a comprehensive avatar description that can be finally used to display and render the avatar. Okay, at the end of this overview, I also have reached the final point of this presentation, which is implementation. And especially in this part where we were concerned with the format of data exchange to ensure the first objective that I introduced, which is beyond interoperability of avatars. Interoperability of avatar, which is not only related to our video conference use case, but also to any other distributed virtual environment where avatars are involved.
Andrea,
so
can you please summarize, because we have to stick to the time. I'm sorry.
Okay, sorry, I lost my my clock. Okay, so first of all, we need to define a standard format for representing avatar model. Then we need to use a standard for body animation and for facial animation. So for the model, we propose to use GLTF, which is an open standard maintained by the Kronos Group, which supports geometry, materials, and animation. And also we support this because GLTF is becoming the standard for geometric representation in the metaverse, as its use is recommended by various organizations like the Metaverse Alliance and the Metaverse Interoperability Group. For animation of a body, we propose skeletal animation, which is a technique commonly used in computer graphics and animation, which involves creating a hierarchical structure of bones to which the 3D models are attached. And this structure is easy to manipulate to animate the models. Okay. However, since most of engines and motion rendering engine motion capture system, they use their own slightly different skeleton definition. We propose also to use the H&M specification as a standard way of representing the skeleton of a humanoid character, as well as their movement and animation. And instead, we propose to use blend shape facial animation to animate the character's face. Which is a method that manipulates a series of predefined elementary expressions, which are called blend shape, that can be combined and blended together to create a wide range of complex facial expression. Okay, and in particular, we propose using a set of standardized blend shape, which are defined according to the facial actor encoding system, which is a system that describes facial expression in terms of specific facial muscle movement, which are called action units. Okay. And this concludes my presentation.